Good evening, everyone. My name is Brahmini Meruva. I'm working as a solutions architect at Open Source DB. Today, I'm excited to share about a real world scenario that we have worked on. It's a case study which is titled as Streamlined Data Flow from Postgres to Parquet and back to Postgres. This revolves around how we handle the data flow from Postgres to Parquet conversion and back to the Postgres in a streamlined way. So this is my title, and I'll go to the agenda. Today in this 40-minute session, I'm going to talk about these. These are the points I'm going to cover: the client requirements and the challenges. So, as I said, we have streamlined the data flow. That is as per the client based on the client challenges and the requirements. And then what I'll talk about what was the solution we proposed as per the challenges. And after that, I'll take you through the implementation of the solution, how we implemented the solution and executed it. Then we will talk about the results and the benefits achieved after implementing that solution to answer the challenges. And then the key takeaways, and finally, we'll complete with the question and answers. So, this is my agenda, and I'm going to the client requirements. So, coming to our client, our client has a Java based application which is deployed on Apache Tomcat. So this application has it is deployed on Apache Tomcat. So it interacts with the PostgreSQL database to manage reconciled data, which is flowing from two different processes, A and B. So the this is the high-end view of the client architecture. So next, I'll go through the database structure. So this is the high-end architecture, like the data is flowing from the Java application to the PostgreSQL database from two different processes. This is the high-end view of architecture. Coming to the database structure, the configuration tables, which are these configuration tables are have the reconciliation logic applied within them to accept the data flow from the A and B processes. Secondly, we have active tables, which holds the current data which is coming from the two different processes, and the other one is backup tables. So the archive data is also residing, coming from both the process is also accommodating in that database itself. So now you understand that whole backed up tables, active tables, and configuration logic, reconciliation logic applied tables are residing on the same database. So you will understand that. Okay, I'll talk about. I gave you that we have active tables, configuration tables, and the backup tables. But the data flows actually into 8 different tables, which currently handling around 8 to 10 GB of data per each table. And as per the client analysis, they'll reach the limit. They'll go in a hike of 50 GB of data. So they want to maintain that database in a scalable way from now to, and after the 50 GB of growth also they want to handle it in a streamlined way. So this is their main architecture of the client. So by now you might understand the problems. We have 8 to 10 GB of data, so it causes database load. So the PostgreSQL database is trained so that it couldn't. Why? Because it is accommodating all the active tables and also the backed up data. So two processors are making the Postgres database to strain and making it making it a problem to scale it. The other one is archived data. So the archived data should be easily retrieved or queried for should be queried for the report analysis. But this is the overload makes it inefficient to query the data properly. So this inconvenience make this becomes a pain point to retrieve the data which is archived into the backup tables. So we are focusing on these 2 points. So now you got the point, like what are we going to achieve? So we have the pain points of scalability issue, database load. So we need to reduce the database. We need to help the database to be scalable when the data load increases. And also we need to easily read the archived data. So these are the main 3 agenda points we have to focus on to work on. So client goals is to so you can understand that client goals are to reduce the database load, to make the data easily accessible. The archive data can be should be easily queried for reporting, and the backup and data, data backed up should be archived in a efficient way and low storage cost effective way also. So these are our client requirements and the challenges and the goals we have to achieve with the solution. So coming to the implementation overview. So as per the client pain points, keeping them on mind, we have chosen this architecture. So here you can see PostgreSQL database, the source database, the client database, which is handling the data. And we have chosen Apache Spark. Why we have chosen Apache Spark? Apache Spark is designed for its speed and its scalability. It is designed for its distributed computing. So this helps in managing high data sets, data workloads. That is the main point that is the main point we have with the client. We need to handle the huge data flows, data sets. So, and one more thing is Apache Spark works on in-memory base, executes the query in memory, so that it makes more transformation when compared to the disk storage approaches. And one more thing is it integrates well with the Python, Parquet, PostgreSQL database. Anything we can do it easily, not tough approaches to be needed. And the other one is cost effective. It is an open source tool, so that we can easily deploy and work on it. So Apache Spark uses, it manages filtering the data. It can transform the data. It can compress the data. We can use for these 3 purposes. The Apache Spark can be used for 3 different things. So for now, we are using it for transformation and compression. We can integrate this Apache, we can convert this PostgreSQL data to Parquet format. We can keep the Parquet files within on-premise, or we can also keep it on S3 bucket cloud as per the need. So it can be integrated with both the cloud. We can also integrate it with the cloud also. That is one benefit from the Apache Spark. That is why we have chosen it. And coming to the Apache Drill. Why Apache Drill? Apache Drill is a SQL-based query engine which easily reads the data from the normal PostgreSQL table with a simple SQL query, and also it will read the Parquet file Parquet data, that is in a compressed way also, in a compressed format also. Apache Drill easily reads with a simple query without putting any load on the database. So we are using Apache Drill. It is also an open source tool. And one more thing is, it is no schema. We don't need to give any schema specifications for reading the table, data from the Parquet files. It is no schema type approach. So this is our architecture, and now we have an idea what is Apache Spark and what is Drill, and where we can archive the Parquet files. So coming to the solution. So now I've said Apache Spark is a distributed computing engine. So how we are using Apache Spark here? So Apache Spark we are using for data extraction from the PostgreSQL table and transforming it to the Parquet files, and along with the compression. compression to make it less storage consumption point, and also cost effective. Then Parquet format, like it doesn't make sense if we just back up data from table to another table. So we are planning to, we are using the approach of Parquet format, which is a columnar storage, and we are using compression. So that in this approach, I'll take you through a demo. In that you can see we have used like 13 GB of data, which is compressed to, in the Parquet file, it is occupying like around 5 GB. So this is the benefit we have. And Apache drill, as I said, we can use simple SQL query for reading the data from the PostgreSQL table, and also compressed Parquet file also, even from the on-premise or S3 bucket. So our approach here, we can use Apache Spark can be integrated with the Python or Java, and we can use different languages to, for coding, for conversions. Here, as per the client requirement, they are using a Java-based application. They need a Java-based code for converting the PostgreSQL table to Parquet file. So we are using, as Apache Spark supports this Java code. We in this demo, I'll showcase it, but we are using Java code for converting the PostgreSQL table to the Parquet file. But we are not using for now, we are using it only for on-premise as per the client demand. Maybe we can use it for the S3 also. And then we also used the code for compressing into, we used Snappy for compressing the data file, so that it will reduce the size of the table, the data file, and it is easy to store. And it is also encrypted, it is the file is stored on-premise or cloud in a secure, safe and secure way. We can read that data using Apache drill. So I'll take you to the demo.
So it should be there in this folder.
I recorded a demo of conversion of Postgres table data into the Parquet files on-premise using both the Java code and Python code. We also tried it with Python, and also we have just done with the PostgreSQL extension, using PostgreSQL extension PG_Parquet. Just to further comparison way, we used all these three. And here is a table aggregator, Recon. In this, I have 8 tables with the data of around 13 GB, 16, like minimum to maximum. I just tried with the different tables with the Python code. And we can also, one more thing is, we can also retrieve the data from the, I mentioned in the title, we can also convert the Parquet file for data back to the PostgreSQL table without any loss also. So here, this is my table, PostgreSQL database with the 8 tables. And here you can see the Spark. In this, I have created table-Parquet, table-Parquet.py. It's a Python code. So this is the Python code we have written. You can see we are using different libraries in Python for converting. First of all, we'll use the connection string of the database. Then we have used a SQL Alchemy, import create engine, and we are using the chunk size to reduce the load on the database. If you read all the data at a time, it will create some load. So we are implementing the chunk size to reduce that load on the database, to query that to convert the data from the table to Parquet file. So here we have used this code. We have also used a timestamp here to know what was the duration of this job execution. So it starts whenever initial, in the first stage of execution of this code, the timestamp starts working, so that we'll know the duration. And we have provided the location of this file, and I'm using for now, I'm using a 13 GB of table, and simply I executed the code by Python 3. Yeah. Could not fast forward. No. Okay. For using Python code for 13 GB of data, it took around 13 minutes of time. It is too long actually. But with the same conversion of, converting the same table using the Java code. Actually, this is not forwarding. I'll showcase that Java code also after few minutes. So in that, using the Java code, the same table conversion has been taken around 3 minutes, 11 seconds. That's the time consuming. And in the Java code, there is a slight difference. Like in the Java code, we have used like partitioning. First of all, we need to initiate the SQL Spark session, which is the first entry point of SQL execution in the Spark. Using that, we'll initiate the Spark jobs. After that, we'll have similarly, we'll give the connection strings, and we'll have we in Java code, we'll use upper bound and lower bound with the partitioning, data partitioning data partitioning to keep data partitioning and for for data partitioning and compression. We are using both. We have used like 200 partitions for 20 million records to reduce the load on the database and to get good execution of the code. Before, we have initially used 100 partitions, but the process is not completing. Up to 99 partitions, it is going well with that chunk size. We have given the upper bound limit, but after that, it is taking too much time. So to reduce that, we have mix and match the partition count, and that gave us like 3 minutes 11 seconds.
Let's try, opening that demo file in another application.
Please. I think it is forward.
Taken half the data out and converted into Parquet. And so how do you know that which rows to delete in the database?
You mean like you're not
actually save the storage, you need to delete the rows, right?
Mm-hmm.
So
sorry.
after the data is archived,
Yep.
you need to delete the
The actually the client approach is like they'll take the backup on daily basis. Like yesterday's data will be backed up today morning. Like they'll take all the data in the table back up the whole data and delete the table for the new data to come in.
Okay.
That's the approach they want.
So they're not keeping any live data. They're not like archiving 1 year old data and keeping new data only. They're just archiving everything.
Yep.
One more question.
Yes.
So once you took the snapshot for the first time, is there any separate process you are following for the next updates?
Like we are not taking snapshots like.
Means once you, the first when you start the process, you took a one snap. Let's consider that as a one snapshot.
Okay. Like we once we have archived all the data in the table.
All the
Yep.
data. Maybe 13 GB
Yeah.
you already converted, and again additionally 1 more GB is came next day for the next day. So are you following the same process or is there any separate process?
Same process, but the data will be archived in, with the timestamp base. Like that, today's data will go into one Parquet file. Next day's data will go into another Parquet file. Like.
That means like next day, like there will be 40 GB of data
Mm.
on the on tomorrow's.
Yes, yes.
Not 14, but only incremental, right? Because you are deleting the old data. Like yesterday's data you are deleting.
Yes. He's talking about archiving one.
Okay.
In
So
PC,
I can add one thought to his question.
Essentially, this is not a CDC system per se, but when we are looking at change data capture, when we are looking at this from a change data capture lens, what we could do is the 13 GB, every hour the 13 GB comes and piles up. So you can look at not only the 13 GB of data, but also the minute by minute data, the CDC, from a CDC standpoint, right? If you can hook up essentially the conversion to Parquet, and then Parquet to getting the data and stuff. So trying the CDC shouldn't hurt is what I feel. But the use case isn't a CDC person, right? It's a they actually have every hour they are coming up with 13 GB of data. So we're looking at 13 into 24 hours of data. So the reconciliation. The whole of that data set is what they are looking at conversion of Parquet, and making sure storage, backup, and all sorts of use cases are sorted out. But to your point, CDC is the way I would go to see how do I break that 13 GB per hour into maybe another 60 iterations of 1 minute per data thingy.
got it.
Like you are done.
We are Postgres guys, so we don't take no for an answer. Thanks to Rajesh and me.
Thank you, sir. So, here you can see it took 13 minutes 43 seconds for converting that 13 GB of data using a Python code. And this is output we got. After that, we have actually worked with a Java code implementation. I'll show you. Yeah, this is. Yeah, after this, I've gone to the other tab where I have Java. Not here. Here I'll execute the Java C. Yep. Compile the. Before that, this is the location where I placed my Java code. That is Apache Spark and examples. There we need to add our Java code, which converts the PostgreSQL database table data into the Parquet format, ensuring that it is scalable and performance efficient. So this is our Java code. As I mentioned earlier, we will first initiate the Spark session, which is the entry point for the Spark functionalities. After that, we'll go with the giving the app as the app name as a Postgres to Parquet conversion. Then it uses all the cores in that system, and it creates a temp directory where to write all the operations, Spark operations there. And then we'll have the connection. We initiated the timestamp here to measure the duration of this job. After that, we'll have the PostgreSQL connection string. Then we'll see, you can see here, we used JDBC format for reading the data from the PostgreSQL. JDBC string. You see the partitioning we have done to read the data to reduce the load on the database. And that is here we have the Java code. First of all, once the Java code, we have the Java code up ready, first we have to compile it. After that, we have to execute it. So I'm using Java C for compiling, and then yeah, and this is how I executed the Java code, and you can see it is running. You can see the partition count. Even we can see it here, or you can also use look at the UI page. We have UI for port number, so you can also go through that UI. Whenever the job is initiated in the terminal, we can watch the same logs and executors, storage, and all that in the UI page. So here you can see the process is running on. So I have mentioned that we are using compression, snappy compression. You can also see it here. Snappy. And it took like committed elapsed time. Like you have 1 second. I'm trying to pause it, but it's going. So you can see the conversion of the PostgreSQL table to Parquet has been completed within this milliseconds. Like this is 3.14 or 3.11 seconds. 3 minutes 11 seconds. And you can see here the yeah. You can see the execution driver 197 out of 200. This is the 197 partition. You can see this much of data is sent to the driver, and the elapsed time is 1 second, 0 seconds based on the type data partition size. It is taking like the seconds of time, and it is the data, the converted Parquet file is in this location. You can see it here, and we can simply we know the location of this of the Parquet file. So we'll give the similar way, we'll use the same code, just we'll make some changes to the code for converting the same Parquet file into back to the PostgreSQL table. I'll also run you with that. Here I took another table, 25 GB, but the row count is same as that 13 GB. Just I have used that conversion using the PG_Parquet. Sorry. Why it is not going? I'm trying to showcase the time actually, but it is going to back and forward. So, as I said, we use the same packet, code for converting this packet file to back to the Postgres table. Here is, this is how we, this is the code we used for that. This also, for this I used just a table with 1 GB of data. It is executed well. You can use also use this same for the 13 GB of data which we used earlier for conversion into the packet file.
Is there any data type conversion issue you faced because of the data type not supported in Parquet and supported in Postgres?
No, actually, I haven't faced the issue. I know it's not moving. I don't know why. I'm trying to.
Can you try opening the video through some other video player?
No.
It could be Windows Media Player problem.
Actually, it is playing, but when I try to fast forward it, it is not playing. After a few seconds, only it is going.
Could be a bug with the video player.
So you can see here we used 1 GB of data for converting. The post packet file for 1 GB. We converted the Postgres table with 1 GB to packet file and retrieved that back to the PostgreSQL table. It took like 4 minutes of time. Similar way, even the compressed data is also can be retrieved. Using the Java, we used compression, right? So we can also convert that compressed data to retrieve back into the table, but it takes a bit more, it consumes much more time when compared to conversion from PostgreSQL table to Parquet. You can check the row count here. After the retrieving also, this is the Java code for writing back from the compressed Parquet file to the PostgreSQL table. Every time when we make changes to the Java code, we need to compile it and then execute. It took like 47410 milliseconds for conversion, writing back into the PostgreSQL table. So this is our solution and the implementation. So after implementing this using Apache Spark for conversion using Python and Java code, we have successfully achieved by archiving the data, backup data out of the PostgreSQL database and reducing the load on it. And using the Apache Spark, it is easy to retrieve the data from the table or even from the Parquet files with simple SQL query. That is one thing. And one more thing is data is archived in a safe and secure way in the Parquet files. So these are the accomplishments we have done after implementing our solution. And make more. Also, one more thing is we prepared the database for the exceeding. As we said, it might increase. Client proposed that they might increase the data to 50 GB. So we made an arrangement that the database holds the additional growth data flow also seamlessly for the conversion also. So this is my presentation and the comparisons we have here. This is the comparison we can check. I've showed you the time consumed with the different approaches. The Python code, it took like 14 minutes. For Java, it took like 3 minutes 11 seconds, and PG Parquet 2.8. And CPU consumption. So this is it. Thank you. Any questions? Yes, please.
So you mentioned earlier that you mentioned earlier in a response to the question around rights that the data will be backed up on regular intervals, and that backed up
Chunk
data is
size. That's what. Yeah.
that backed up data is what we are querying using Parquet files. Am I understanding it correctly?
Yes.
So how exactly? So if we're querying the Parquet files, this means that the system itself is quite efficient for read queries.
Yes.
How exactly does write? How exactly do you handle write queries effectively? And in case your entire system was write heavy, how will you modify this?
Like you are asking about the Postgres conversion of the table to the packet is heavy, I mean loaded.
No. So Parquet files are immutable.
Yes.
And which is why you probably have to recreate those Parquet files at regular intervals, if I understand it correctly.
You are not recreating.
You're not recreating the files? So how exactly are you updating the Parquet files? In case I make a write query,
Yeah.
how exactly does that get updated in that specific Parquet file?
I think this is about the old and obsolete data. Archiving those data.
You are not adding that to the data.
So it won't be updated further.
Okay.
Parquet file is for backing.
What happened last year?
So this is primarily for archive data and
Yes.
not for the latest data.
Yeah.
Okay.
You are archiving using the you are archiving the data using the Parquet, not the existing live data.
Okay, makes sense.
Yes.
And
Please.
what is the purpose of transitioning from Parquet to DB, PGD?
If we need to read the data, I mean, you are asking that Parquet file back to the table. What is the purpose of that?
Yeah.
If they need.
So that means the DB data will be entirely erased and only Parquet file will be there, is it?
Yes.
Okay, so how do we handle data loss strategies? Something happens.
We
While
also have
process-
reconciled tables.
Hmm?
Can we answer it like the live data is residing on one table, and we also have some reconciled tables. From there, data
So
is backed
again
up.
we reconstruct the table and then generate the Parquet file and then query the Parquet file. That's how it is.
Parquet file is also already existing. Why are we recreating it? Sorry,
First thing
I
is,
missed that
Yeah,
question.
so in a general business scenario, how it happens is there will be retention policies. Basically, the business says that in years we will retain the main data. And the remaining data can be archived to the archive system. It may not be on the live system. But if there is say, for example, there is a case, historical data needs to be retrieved. So then the fork may say that bring back the 5-year data. So that old data may have to be
so we
restored
transform into Parquet file.
Yeah, with the archive can store it.
Store it, and from that Parquet file we generate a Parquet file. Correct, right? No?
So essentially, if I come now,
Something like this with
what we are looking at is, we have got Postgres and then Postgres to Parquet file.
Correct.
That's the first step, right? For us to look at archiving, for us to make sure the whole database size is not going, ever. At some point of time, like Jobin said, some court case or some requirement has come up which says, hey, get me the data which is of January 2020. And we've got Parquet files. So we are bringing back that Parquet files, and then there are two ways of doing it. One is you directly look at that Parquet file within your indexing strategy, whatever the indexing strategy you have on top of Parquet. You go ahead and say, these are the queries that I'm sending across, and then within the 2024 realm of all the Parquet files, get me this data set. Or you bring the 2020 data and then from Parquet to Postgres. These are two ways of doing it. So which way you are looking at is no totally how much of data set we are going to be grabbing of January of 2020.
So here for the first doubt was, why do we move from Parquet file to PG again?
Again, it is case to case basis. If there is a requirement,
What
we
would
will
be
bring the
such a
data.
requirement?
So the exact case that Jobin had mentioned, if somebody wants to, Parquet files cannot be read. You will not be able to take a look at Parquet file and say, hey, this is the raw data, because it's a columnar file. Right?
Correct.
So for us to look at that data and then make meaningful use of that data, you won't want that Parquet file to be Postgres, into a Postgres table.
Okay, so my assumption was Parquet file will be created only if there is a Postgres tables.
So Postgres tables to Parquet is the happy part.
Happy path, correct.
Right, so when you are grabbing the data from Parquet file off of drill, right, you will be able to write SQL queries, simple SQL queries from the Parquet files. You will be able to grab the data. That's good. But if you want the Parquet files to be again moved back to Postgres tables for some reconciliation, for some compliance management, or for any of the reasons, that is also possible. Is what Brahmini is actually demonstrating.
Restore kind of.
Yes.
So there is no chance that we will lose Parquet files.
I mean, as long as your storage is fine.
DR is maintained.
During process.
During the process, no. The whole encapsulation is pretty rock solid. And then this is not something we have been doing of late. They have been there for a while.
Okay. Yeah, so the question was majorly towards data consistency. Resilience.
Yeah, more of resilience than consistency, I would say. Yes, please.
So just a follow up to what I had asked earlier. This approach will be useful for when the data is similar to how audit logs are. Am I understanding it correctly?
Yes. Yes.
Okay.
One of the cases that this case study is actually built on is on auditing.
Because I was a bit confused about how exactly the data is not changing. What happens if you have to change an old data? So
Correct.
in that case, I'm not sure how this approach will work. So that's why I thought to confirm.
Good. So we have the last topic, Ashwini, please.